forces. If we talk about forces, so this is nothing but an agency that will changes or tends to change the motion of a body, or we can say the state of the state of rest of a body. If we take an example and we take a basic example of our vehicle, so let us take a small car. That car would be, that is in this position right now, and in this car engine provide a force P in this particular x direction. So we previously defined that force is an agency that will change the particular state of the rest or motion of a body. So in both the way that may also increase or may decrease the motion. So when this car is affected with force P in this particular direction, but at the same time, if any force F that is available in opposite direction to that force P, so that will change the motion of that particular car. So here we consider different three cases for the this applied forces. So if that F that is greater than P, so what happen if value of force F that is higher than the value of force P, so the car that will move in direction of force F. In second case, if we take that F that exactly same as the P, so in this condition that car will exactly come to the rest position, and if that F value that is lesser than a P, so what happen, that car will moving in direction of force P, but due to this applied force in opposite direction of this P, whatever the P generates the velocity in the car, that will be reduced by this F force. So we can say that, but it is with lesser velocity, right? So in this condition, these three conditions are arise when different type of forces are acting on a body. Now generally when we want to define a force, so we have to consider force as a vector quantity, force as a vector quantity. Why it is a vector? Because here we see that actually to define that force we have to provide some magnitude in form of either a P or F, and also define some particular direction. So any quantity that required a value of the magnitude and a particular direction, that we generally call as a vector quantity. Now, to characterize this force, following three characteristics of a force that is very much important to define force in its particular way. So let us take one by one. So first one, that is magnitude. This is very much important to define a magnitude of a force, because without a magnitude that will be a no force. So if we want to define it, so that is simply written with some value, so that is in either a 50 kilonewton or that is 30 kgf. So here this is in a SI system and this is in a MKS system. So force required sum of the magnitude with some particular unit here. Now if we take a second characteristics, that is direction, that is also very much important, because without direction we cannot know that in which side the force will be acting, so either that is in positive direction or a negative direction. So that is also very much important. So it generally indicates the angle and the sense of the force. So if you want to write down, we generally write down that 50 kilonewton acting in north direction. 50 kilonewton acting in north direction. So we realize that this is a particular direction of the force. Now the third thing that is also very much important in mechanics to study proper application of the forces. So third one is point of application. Now that indicate which is the point where force is exactly applicable. So it provides a position or the location at which the exact force is acting. Now after that, so we can just write down here, it provide a location and a position of a force. Now after these three characteristics we have to define, or we have to represent that force in a graphical form. So it is in this particular way. So let us say this is a one arrow, and that arrow has some body, and it is a head of that arrow, and this is a tail of that arrow. Now in this particular arrow we have a head, body and a tail. Now if we look at to the whole length of this arrow, that is generally indicate magnitude, right? And this point, or we can say the tail, that is indicate a point of application. And here a head part, that indicates direction. So this is a proper way to represent a force in a graphical form. Now, after that, the representation and the characteristics. One major important thing, that is a unit to define a force in a particular way. So in SI unit, if we want to consider a force, so force is in Newton or in kilonewton. Whereas in MKS system, MKS unit of the force, that is kgf. kgf, this is generally known as a kilo force. Here 1 Newton is defined as the force required to produce an acceleration of 1 meter per second square of body of 1 kg mass. Right? The meaning of that is kgf, kg force, that is force required to produce a acceleration. Right? How much is the acceleration? So acceleration is nothing but 9.81 meter per second square of what? So kgf is a force that requires to produce this much acceleration of 1 kg mass. 1 kg mass. Okay, so if we see that mathematically, so 1 Newton is equal to 1 kg into 1 meter per second square, and 1 kgf is equal to 1 kg into 9.81 meter per second square, right? Or you can say that 1 kgf is equal to 9.81 meter per second square. So this is an important conversion formula which is used to converting force in kgf units to newtons units or vice versa. So here if we look back to the forces, that is nothing but agency that will change the state of the rest, that will increase or decrease the motion in particular direction. The direction that is completely decided by the force, or we can say the higher force that is acting in a particular direction, and it is nothing but a vector quantity, so it requires magnitude, direction, and also a point of application to define it in correct way. And this is a graphical representation of a force. If we talk about a unit, so in SI unit it is generally defined by Newton or the kilonewton, and in MKS unit that is in kg force. And if we talk about the conversion of that, that is 1 kgf is equal to 9.81 Newton. 1 kgf is equal to 9.81 Newton. So this is all about forces.